I connected a capacitive soil moisture sensor to my ESP32. I expected when we get wet soil, the reading is high, and the dry soil we get low reading. What I got, the exact opposite. If this happened to you, you are not doing it wrong. The sensor is just not doing what the label says. Let me show you what actually happened and how to fix it in 2 lines of code. There are 2 types of soil moisture sensor, as we know. The first is resistive. It has to expose metal probes. At first I will search on Google resistive soil moisture. Yeah, we got the image, and then I will show you. Yeah, this is the image of resistive soil moisture sensor, and in camera we see our capacitive soil moisture sensor. We have capacitive soil moisture sensor V2.0, and in resistive soil moisture sensor we have 2 metal probes, and when water conducts electricity, so wet soil, we get lower resistance and high current and high reading. Simple, straightforward, but this corrode fast. This sensor will corrode fast. The second is capacitive. It has coated PCB. We can see at camera. No exposed metal like resistive soil moisture. It measures how water changes the capacitance of the soil around it. More water, higher capacitance, higher reading in theory. Yeah, and here's the problem. Some capacitive module like mine, especially the cheap ones like like this one, are wired in a way that flips the output. Yeah, the sensor physically detects more water correctly, but the voltage output goes down when it should go up. When you read it with analog read in our program here, when we read it with analog read like this one, dry soil gives you a higher number, wet soil gives you a lower number. I found this out from not from a dataset, but from sticking the sensor in actual soil and watching the serial monitor. Now the conversion formula that we see in our code program to convert a raw ADC value to a percentage. Most tutorial tell you this. Yeah, most tutorial tell you float moisture raw value, float ADC, float. We have variable here, variable moisture with data type float, and we have raw value The raw value is the data that we get from the sensor, the raw value, and we divide it with ADC max. ADC max in in ESP32 we have 4095, and in Arduino we have 1023, like this one, and we times 100. It means we want to convert it to be percentage. This works if more water equals higher raw value, but if your sensor is flipped like mine, like my sensor, you need this instead. Let me see. Yeah, if your sensor flip like my sensor, we need this formula, which is moisture. We have moisture variable, and we have 1 here, and then we minus raw value, and then we divide by float ADC max, and then we times 100. We subtract from 1, which is invert the result, and then now our high raw value is equals low moisture percentage. Dry is 0% and wet is 100%. Let me see in our serial monitor. In our serial monitor, we have status dry. Let me see, dry here, and the moisture value is around 9%, and our sensor is not in soil, in wet soil, so our formula is correct. One more thing, ADC max depend on your board. Remember it, Arduino Uno, because we use 10 bits ADC, so the ADC max value is 1023, and in ESP32 like this one, I use ESP32 S3 because the board is 12 bit, so the ADC max is ADC max value is 4095. So instead of hard coding, I use logic like this, so our program is have a flexibility like this one. So this code will automatically adjust based on which board you are using. No manual change needed when you switch the hardware, like this one. If we use ESP32, the ADC max we use is this, and soil pin in this. And if we use another board except ESP32, which is Arduino, the program will detect and use soil pin in A0, and ADC max is 1023. And then let me show you the full working code and demo. I also add a status output, not just a number but a decision. If the value, the percentage of the sensor is below 30%, the status is dry and we need water. and if the value is from 30 until 70, the status will be optimal and plan is safe. And else, if the value is more than 17, the status will wait and pump does not need to turn on. Okay, this is the foundation of an automatic irrigation system. The sensor reads, microcontroller decides, later a relay acts. Let we upload this code. We close the serial monitor, so our communication, our laptop communication with our board does not have any problem. We use upload here, compiling sketch, we wait for it, and then done compiling and uploading, we wait for it. Okay, we get done uploading here. We open the serial monitor and we can see here our sensor is successful to read the data from sensor. And if we try to hold the sensor, the value, the raw value, and the moisture will goes up like this one. You can see when the value is more than 30 and below 70, the status is optimal and plan is safe, like this. We success build our project. And when we release our hands from the sensor, and sensor in open air, we just simulating dry condition. The serial monitor, we can see here, will status dry and pump must turn on, like this one. And now because I don't have water, I just want to hold it like this one, and we can see the moisture value goes up like this one, and we have the correct direction, correct percentage, and status logic is working. To summarize, if your capacitive sensor reads backward, like when the soil is wet but the value of moisture goes down, you can use this formula instead. You can use this formula. If you're switching between an Arduino and ESP32, use conditional ADC mix like this one, and then always test on real soil, not just in the air, like what I do. And the code from this video is on my GitHub, link in the description, so you can visit the GitHub and download the code and try it on your on board. In the next video, I'll connect the sensor to a relay, or maybe we can use LED, this sensor, and build automatic watering logic. The sensor will turn a pump on and off by itself, no manual input. If this helped you, subscribe. See you in the next one. Thank you.